Hey guys, so this is the first of our Flipping the Classroom videos. It's going to work just like all of my other lecture notes where things are highlighted and color-coded for you, and I might be writing on the slide. You hear jingling in the background, that's my bracelet. I'm actually going to take it off so that sound doesn't become annoying. So, our new topic, which is going to take us into the second 6 weeks, is about mass number and atomic mass. And your mass number is kind of like your proton number. So we're still talking about atoms. So let's do a little bit of review about some of the scientists that discovered the atom, and then we'll get right into mass number and all that other stuff. Okay, so James Chadwick, like I told you before, was the scientist that discovered the neutron. And once that discovery was made, now we had kind of like the whole picture of what the atom looked like. Because before he discovered the neutron, everyone thought that the atom just had protons and electrons. That's it. So when Chadwick discovered the neutron, he completed the understanding of the atom. Again, he was a student of Rutherford, so Rutherford kind of taught him most of what he knew. Okay, so remember Dalton. Dalton was the guy who kind of came up with the whole idea, okay, there are things that are smaller that make up things that are bigger. When Chadwick discovered the neutron, he changed one of the initial thoughts or discoveries that Dalton had made. Dalton thought that every single atom of every single element was identical. But through the discovery of the neutron, we figured out that that's not true. All atoms of a specific element are not necessarily identical. So all carbons are not identical. All nitrogens are not identical. All oxygens are not identical. Some atoms have a different number of neutrons. So their proton number is the same, their electrons are the same, but their neutrons, that number is different. So I have a new word to teach you. It's the word isotope. And I'm sorry that this is not on the line. When I put the video together, it kind of shifted some of the settings. So the word isotope means atoms of the same element with a different number of neutrons. So again, an isotope is an atom of the same element with a different number of neutrons. So for example, there are like 4 types of carbon. There's carbon-12, carbon-13, carbon-14, and what's different between them is how many neutrons they have in their nucleus. Same thing with hydrogen. That's the example that I'm giving you here to the right. There's hydrogen-1 that actually has no neutrons in its nucleus. There's hydrogen-2, which only has 1 neutron in its nucleus, and hydrogen-3, which has 2 neutrons in its nucleus. We'll talk more about how we discovered those later. Scientists call the electrons, protons, and neutrons subatomic particles. So when you see the term subatomic particles, sub means like under, so under the atom almost, they're referring to protons and neutrons and electrons. So I want you to look at these pictures for me. The protons and the neutrons are about the same size. But now look at the electrons. They're a whole lot smaller, and it has to do with their mass. Your protons and your neutrons weigh about the same. They have a relative mass of about 1. Whereas your electrons are really, really small. We're talking about 1 out of 1840. That's really tiny, like a really small decimal. So they don't really weigh that much. So when we calculate atomic mass, we actually don't pay attention to how many electrons or the mass of the electrons in an element or in an atom. So Why don't we consider them? Well, it's because they're so small. They don't really contribute towards the overall mass because they're really, really tiny. It's almost like your mom asked you to carry in 8 bags of groceries with milk and canned foods and, I mean, heavy things. And then she takes the receipt and she puts it on top of one of the bags. Does the receipt really change how much weight you're already carrying? Not by a whole lot, so you don't even pay attention to it. Same thing here. The atomic mass is going to come from the protons and the neutrons. The electrons just don't add a whole lot of mass, so we don't really think about them. So, how do we find our mass number? Our mass number is how many protons we have plus how many neutrons we have. Your mass number is not your atomic mass. Okay, so again, mass number is how many protons plus how many neutrons. Mass number is not the atomic mass. So if you look at the pictures, and again, I'm sorry that the labeling is a little skewed, but if you look at the picture, let's start with hydrogen. We have 1, 2 things in the middle. The proton's positive, the neutron's neutral. This hydrogen has a mass of 2. If we look at this lithium, it has 7 things in its nucleus. 1, 2, 3, 4, 5, 6, 7. So that's how we come up with a mass number of 7. Helium has 4 things in its nucleus. 1, 2, 3, 4. That's how we come up with the number 4. So you're literally just adding the protons and the neutrons to find your mass number. Does the mass number tell you the number of neutrons in an atom? No, it doesn't. It tells you neutrons plus protons. So to find neutrons by themselves, you have to take your mass number and subtract the atomic number from that. Where do you find your atomic number? It is on your periodic table. So you look on the periodic table for this. The mass number, remember, is protons plus neutrons. And when you subtract the 2, you get neutrons by themselves. So for example, if I asked you how many neutrons does helium have in it, so here's the periodic tile of helium, and we know that helium's atomic number is 2. We know that they told us here that this is helium 5, and again we can verify by counting what's in the middle. So 1, 2, 3, 4, 5. So 5 minus 2 equals 3. 3 neutrons. It's a simple subtraction. You just have to remember what you're minusing from what. Okay, so we talked about isotopes a little earlier. We said that an isotope is just like a different version of a particular element. It's when they have different numbers of neutrons. So how do we find or identify isotopes? They're identified based on the number of protons and neutrons in the atom. So again, you're adding up what's in the nucleus. So on quizzes and stuff, I might tell you this element has 5 protons and 6 neutrons. Well, this 5 represents your atomic number. And that is on the periodic table. So you take out your periodic table, you look for the element that has the number 5, and that will tell you the name of the element. So when I look at 5, I know I'm looking at boron. To figure out what isotope, that's where I add my protons and neutrons together to give me my mass number. So this is my mass number. And this isotope would be called boron 11. So again, the 5 tells you what element it is, and the mass number you get from adding your protons and your neutrons together. Okay, and we always connect the name of the element to its number with a little dash. So if you look up here, you can see that little dash. That's how we always connect them. And we use that dash to show that these two go together. They belong with each other. Okay, so I want you to do some practice for me. Determine how many neutrons are in each of the isotopes listed on your notes. And it tells you 13, 3, 19, whatever. I want you to try to work it out for me for a little bit. And then we'll go through and I'll give you the answers. Alright, so here's the same thing with all the information filled in. So go ahead and just copy this down on your note sheet. Alright, again, to find the neutrons, don't forget, you're taking your proton number and subtracting that from your mass number. To figure out the isotopes, you're looking at the number of protons, finding that number on the periodic table to give you the name of the element. And then you're just attaching how many neutrons, you're adding the neutrons and the protons together. So here and here, we're going to add those together to get your isotope number. Alright, hopefully you're done. Guys, don't forget, because this is a video, you can always pause me if I'm going too quickly, or rewind, or whatever it is you need to do. Okay, so because atoms are so small, we can't actually look at them through a microscope and count them. Oh, there are 3 atoms, there are 12 atoms. So instead what we do is we use a really large number to describe them. This number is known as Avogadro's number. So Avogadro's number is this number right here, which is really, really big. And in science, we don't write big numbers out. We do scientific notation. Remember, there's a decimal right here, and you're just going to move that decimal over and over and over and over and over and over until it ends up there, and then you count how many times you move it. So Avogadro's number, you need to write this down. Avogadro's number is 6.02, and that should say times 10 to the 23. And 23 should be written as an exponent. So I'm going to rewrite this for you. Avogadro's number, find some space, is 6.02 times 10 to the 23. So write it like this, not like that. Okay? So again, Avogadro's number is 6.02 times 10 to the 23. When you have that many particles, we describe it as a mole. So a mole is a measurement in chemistry. 1 mole is equal to 6.2 times 10 to the 23 particles. So you don't find the number of neutrons on your periodic table, because the atoms of the same element are going to have different numbers of neutrons. So you can't really list them because the periodic table would be really big. You'd have to say carbon 12 has this many, carbon 13 has this many, carbon 14 has this many. So we don't ever put the number of neutrons on the periodic table. So when we talk about a mole of a certain element, like chlorine for example, the ratio of each kind of isotope of chlorine tends to be consistent. So for example, in 1 mole of chlorine, about 75 of the atoms are going to be chlorine 35, and about 25 of them will be chlorine 37. And that number is going to change depending on how many isotopes you have. Right, so again, this is the same example we just went over in the slide before. Now let's talk about atomic mass. So we talked about mass number. Now let's talk about atomic mass. Atomic mass is what you find on the bottom, and it's always a decimal. So this right here is atomic number, And it is not a decimal. It's always a whole number, 1, 12, 24, 267. But atomic mass, which is on the bottom, is going to be a decimal. The atomic mass is a measurement of 1 mole of that element. And again, 1 mole is the same as saying 6.02 times 10 to the 23 particles. Okay? This number is on the periodic table because it doesn't really change. The value pretty much stays the same. So consistent just means stays the same. Okay? The atomic mass is calculated from a ratio of each kind of isotope in that element. So they kind of like figure out every kind of isotope that makes up that element, and then they kind of take a ratio of it out. This many of this, this many of this, this many of this. Let's add it all together. There is our atomic mass. Okay, so your atomic mass is a sum. I hope you remember that sum means to add, right? When you see sum in math, it means add. Well, sum in science means add as well. So it is a sum multiplied by the mass number times the percent of that isotope. So you find the value of the mass number times the percent isotope for each isotope, and then you add them together. Like this would be chlorine 35. And remember I told you it's 75%. So we do 35 times 75. And then 37 is the other isotope of chlorine. That's about 25%. So 37 times 25 gives you the other number. And then you add the two together, and what you end up with is 35.5. And that is measured in grams per mole because grams represents weight and moles represents our particles. So the easy way to put this into your calculator, because you can use your calculator, would be to put the percentage in as a decimal. So technically, 75% is the same as saying 0.75. Because when we think about it, it's really, hold on, let me erase that for a second. Make it a little smaller. 75% is the same as saying 75 out of 100. So 75% is equal to 75 divided by 100, which is equal to 0.75. So that's how you can put it in the calculator. You can do 35 times 0.75. It's the same thing as saying 35 times 75 over 100. You still get your percentage. Alright, so here's another example. In a mole of boron, about 80% of the atoms are boron 11, and about 20% of the atoms are boron 10. So they pretty much want us to figure out what is going to be the atomic mass. What is the appropriate atomic mass of boron, atomic mass of boron based on this data? So remember, we would do 11 times 0.8 and 11 times 0.2. And then we'd add those two sets of numbers together, and it would give us 10.8 grams per mole. Now in chemistry, it's really important that you put these units, because the units tell you what the numbers mean. If you just put 10.8, that doesn't mean anything to me. So make sure you're writing your units down. All right, here's another one. In a sample of an unknown element, X, the ratio of isotopes is examined. It is determined that 89.80% of the sample is composed of 1112X, and the other 10.20% is composed of 114X. Based on this data, what would be the atomic mass of element X? So again, we're going to take our 1112, because that is our excuse me, that is our isotope number they gave us. And we're going to multiply that by 0.8980. And we're going to add that to taking 114 and multiplying that by 0.102. And the answer would be 112.2 grams per mole. Okay, so in this situation, you're always multiplying and then adding together. Okay, so there's supposedly a tune that someone in the district made up for you guys to help, to help you remember what this is. When you come to class, I'll play the tune for you because I don't really know it. But if you just will repeat these things to yourself, you'll remember how to solve. It's always mass times percentage plus mass times percentage. So you take the mass, you multiply it by the percentage. You take the other mass, you multiply it by the percentage. You add the two together, and that is how you solve for isotopes. Alright, so this is it for the video lesson. I'll see you guys next class. Bye.